Hello students, welcome to the tutorial of Advanced Data Structures and Algorithm Laboratory. In this tutorial, we are going to see about the shortest path algorithm, Dijkstra and Bellman-Ford algorithm. So, what is shortest path? To identify the shortest path between the two vertices, which is called the shortest path. So, we are using the two algorithms. One is a Dijkstra's algorithm, another one is a Bellman-Ford algorithm. So, Dijkstra use the property in the opposite direction. For example, this is the implementation of Dijkstra's algorithm to identify the shortest path between the two vertices. So this is the graph which we are going to be identifying the shortest path between source and the destination. So here we are selecting a node with 0. So 0 is going to be the start node, and the remaining all the weights is going to be initialized as infinity, which is maximum. Okay. Then choose a starting vertex and assign the infinity path values of all other devices. So we are starting with 0 and all other vertices, it's making the distance is going to be infinite. And step 3, go to each vertex and update its path length. Okay. Then if the path length of the adjacent vertex is lesser than the new path, then don't update. So we should keep minimum as possible. And then avoid the updating path lengths of already visited vertices. So we are going to be selecting not visited vertices and keep on updating their path length, which is minimum. And after each iteration, we pick the unvisited vertex with the least path length. So we can choose 5 and 7 before. We can choose 5 before 7. Okay. Then notice how the rightmost vertex has its path length updated twice. Repeat until all the vertices have been visited. So this is the Dijkstra algorithm pseudocode, which is nothing but, see, we have to take all the vertices and starting with one of the vertices, and the length of all the vertices should be infinite at first time, and each and every time we have to go for that vertex and we are updating their length. If it is a lesser, and we are going to be updating. If it is not lesser, we are keep on that. So keep doing until all the vertices going to be visited. Okay, let's be implementing the Dijkstra's algorithm in pseudocode. So this is the Dijkstra's algorithm implementation. So we can have the graph structure, and we have in the minimum distance. Okay, the distance and then Boolean variable for visited and non-visited. So this is the graph. We are going to be identifying the minimum distance between source and all the destination with the help of Dijkstra. So I am going to be implementing. So this is the graph with equal weight. So this is the vertex and the distance from the source. So the source vertex is going to be 0, the distance is going to be 0, and from 0 to 1, the minimum distance is going to be 4. The shortest distance is going to be 4. And 0 to 2, it is 12. The 0 to 3, it is 19. In 0 to 4, it is 21. In 0 to 5, it is 11. In 0 to 6, it is 9. And 0 to 7, it is 8. In 0 to 8, it is 14. So we are having 8 vertices, and we have the shortest distance between the 0 to each and every vertex. We move on to the next algorithm, which is called Bellman-Ford algorithm. So why we go for Bellman-Ford algorithm instead of the Dijkstra's algorithm? The Dijkstra's algorithm will not satisfy the negative weights because it doesn't care about. So the shortest path algorithm like Dijkstra that aren't able to detect such a cycle can give the incorrect result because of they can go through a negative weight. So okay, so the negative weight in previous days it is not that much important, but later days the negative weight will have the most impact on a lot of applications. So the Bellman-Ford algorithm is going to be what following steps. To start with the weighted graph, we know, and step 2, choose the starting vertex and assign the infinity path values to all other vertices, and visit each edge and relax the path distance if they are inaccurate. In the similar way, we are going to do this for v times, because in worst case a vertex path length might need to be readjusted at v times. So notice how the vertex at the top right corner had its path length adjusted. Okay, you already see that. Okay, so this is the algorithm implementations. So initially we have to set the infinitive, and each and every iteration we are going to be updating the path length. Okay, and finally we have the shortest path with negative cycle. So this is the pseudocode for implementation. Let's be implementing the Bellman food algorithm. So we have source, destination, and weight. Okay, so this is the way we are going to be constructing the graph. So source is going to be 0, destination is going to be 1, and the weight between 0 and 1 is going to be -1. So in the similar way, we are going to be creating the graph and implementing this Bellman food algorithm, which give you the shortest path in your graph with negative inputs. Okay, so this is the vertex distance from the source. Here our source is going to be 0, because we are giving the Bellman food algorithm with graph. The source is going to be 0. So 0 to 0 is 0, and 0 to 1 is -1, 0 to 2 is 2, 0 to 3 is -2, 0 to 4 is 1. So I hope this Bellman food and Dijkstra algorithm is well understood by this explanation. So I will see you in next video. Thank you.